In this video, we will practice finding arc length, which is the length of a piece of a curve. This is a BC only topic. This is a practice video, so we're going to run through several examples. If you haven't already watched the introductory video, you should definitely watch that first. This video will make a lot more sense if you do. You can either click the link that appears in the upper right hand corner or find the link in the description. Find the arc length of the graph of the function over the indicated interval. For number 4, we need to find the length of this curve from x equals 1 to x equals 2, and we need to do it without a calculator. This is the formula for the length of curve y from x equals a to x equals b. And here's the version of the formula written with respect to y. Pause the video and memorize these formulas if you have not memorized them already. In order to set up this formula, we are going to need the derivative, y prime. To make it easier to find the derivative, we can rewrite the original equation like this. Taking the derivative term by term gives us this. This is an expression for the length of this curve from 1 to 2. If we were allowed to use a calculator, I would type all this into the calculator and hit enter, and I'd be done. Sadly, for this problem, we are not allowed to use a calculator. So we need to simplify as we go along, working from the inside out. So let's start with the expression that's under the radical. Our only hope of being able to integrate this without a calculator is if this turns out to be a perfect square. That way the radical and the exponent will cancel each other out. We need to get rid of these parentheses. Please remember that you can't just square each term separately. Instead, you need to multiply binomial times binomial. 1/2 x squared times 1/2 x squared is 1/4 x to the 4th power. 1/2 x squared times negative 1/2 x to the negative 2 power is negative 1/4 x to the 0 power, or simply negative 1/4, since x to the 0 power is 1. Negative 1/2 x to the negative 2 power times 1/2 x squared is exactly the same product that we just did, so we will get negative 1/4 again. And negative 1/2 x to the negative 2 power times negative 1/2 x to the negative 2 power is positive 1/4 x to the negative 4 power. Combining like terms, negative 1/4 minus 1/4 is negative 1/2, and then 1 minus 1/2 is positive 1/2. So now we have this. Remember, all of this is sitting under a square root in the formula, so the only hope of simplifying is if this factors down to a perfect square. We need it to be the same binomial twice. So let's shoot for that and then sort of see if it works out. 1/4 x to the 4th power can be factored as 1/2 x squared times 1/2 x squared. Similarly, 1/4 x to the negative 4 power can be factored as 1/2 x to the negative 2 times 1/2 x to the negative 2. But will this binomial times itself give us the original trinomial? To make sure this product will actually give us the trinomial, we need to make sure that the inner plus the outer equals the middle. When I talk about the inner, I mean the product of these two terms. And 1/2 x to the negative 2 power times 1/2 x to the 2nd power is 1/4 x to the 0 power. In other words, 1/4. When I say outer, I'm talking about the product of these two terms, but this is the same product that we just did, so we end up with 1/4 again. So inner plus outer is 1/4 plus 1/4, which is 1/2. And guess what? That's the middle that we were shooting for. So this works. Since we have the same binomial twice, we can write this more compactly as binomial squared. Remember, all of this goes under the radical in the arc length formula. So this is an expression for the length of the curve from 1 to 2. The radical sort of unsquares this expression, so the radical and the exponent cancel each other out. So now we have this. Let's take the antiderivative term by term. Increasing this exponent by 1, we have x to the third power. Then we divide by the new exponent. 1/2 divided by 3 is 1/6. Moving on, increasing this exponent by 1 gives us x to the negative 1 power. Dividing positive 1/2 by the new exponent of negative 1 gives us negative 1/2. Next, we apply the limits of integration. So we need to find the value at 2 minus the value at 1. So here's the value at 2 minus the value at 1. Simplifying a little bit and distributing this negative sign gives us this. Forming like denominators gives us this. And combining like terms gives us this for the final answer. This is the length of the curve from 1 to 2. Of course, on a free response question, we could have stopped here. We did not need to simplify our answer. Let's rewrite number 8 a little bit to make it easier to take the derivative. Now, if we take the derivative term by term, we get y prime is equal to 1/2 x to the third power minus 1/2 x to the negative 3 power. Here is the arc length formula that we are trying to set up. But let's start by setting up just the part under the radical. Remember, we can't get rid of the parentheses by squaring each term separately. Instead, we need to expand by multiplying a binomial times a binomial. 1/2 x to the third power times 1/2 x to the third power is 1/4 x to the sixth power. 1/2 x to the third power times negative 1/2 x to the negative third power is 1/4 x to the 0 power, or simply negative 1/4. Negative 1/2 x to the negative 3 power times 1/2 x to the third power is the exact same product that we just did, so we're going to get negative 1/4 again. And negative 1/2 x to the negative 3 power times negative 1/2 x to the negative 3 power is positive 1/4 x to the negative 6 power. Combining like terms, negative 1/4 minus 1/4 is negative 1/2, and 1 minus 1/2 is positive 1/2. Remember, all of this sits under the square root symbol in the arc length formula, so we are really hoping this turns out to be a perfect square trinomial. In other words, we are hoping that this factors as the same binomial twice. So let's go for that and just see if it works out. 1/4 x to the sixth power factors as 1/2 x to the third times 1/2 x to the third. And 1/4 x to the negative 6 factors as 1/2 x to the negative 3 times 1/2 x to the negative 3. To make sure that this binomial times itself really gives us this trinomial, we just need to check to make sure that the inner plus the outer is equal to the middle. When I say inner, I'm talking about the product of these two terms, and 1/2 x to the negative 3 times 1/2 x to the positive 3 is 1/4 x to the 0. Or we could just say 1/4. When I say outer, I'm talking about the product of these two terms, but this is the exact same product as inner, so of course I'm going to get 1/4 again. 1/4 plus 1/4 is 1/2, and that is the middle that we were shooting for. Since inner plus outer equals middle, this product does equal the trinomial. And since this product is the same binomial twice, we can write it more compactly as binomial squared. All of this goes under the radical in the arc length formula, so this is our expression for the arc length. The radical and the exponent cancel each other out, so now we have this. Let's integrate term by term. Increasing this exponent by 1 gives us x to the 4th power. Dividing 1/2 by 4 is 1/8. Increasing this exponent by 1 gives us x to the -2 power. Dividing 1/2 by -2 gives us -1/4. Now we apply the limits of integration from 1 to 3, so we need to find the value at 3 minus the value at 1. So here's the value at 3 minus the value at 1. For a free response question, I would recommend leaving your answer like this, no need to simplify. But let's keep going to see what the answer would look like for a multiple choice question. Simplifying a little bit and distributing this negative sign gives us this. On the next step, I'm going to subtract 81 over 8 minus 1 over 8. So that's going to be 80 over 8. Of course, 80 over 8 reduces to 10. Making like denominators gives us this, and combining like terms gives us this, which simplifies to 92 over 9. So this is the simplified arc length. Number 12. The first step is to find the derivative. Think of this as natural log u. So y prime will equal 1 over u. But because of the chain rule, we have to multiply by the derivative of the inner function. The derivative of cosine is negative sine. So y prime is equal to negative sine over cosine, which is equal to negative tangent. Ultimately, we need to set up this arc length formula, but let's start by just setting up the part under the radical. 1 plus y prime squared becomes 1 plus negative tangent x squared. When you square a negative, it becomes positive. So we have 1 plus tangent squared x. Does this look familiar to you? If you remember your Pythagorean identities, you will recall that 1 plus tangent squared is equal to secant squared. So secant squared is what goes under the radical in the arc length formula. On the next step, the square root and the exponent will cancel each other out. The antiderivative of secant is a memorized rule. It's the natural log of the absolute value of secant plus tangent. Since this is a definite integral, we must apply the limits of integration from 0 to pi over 3. This means we need to find the value at pi over 3 minus the value at 0. Here is the value at pi over 3 minus the value at 0. Secant is the reciprocal of cosine. The cosine of pi over 3 is 1/2, so secant will be 2. The tangent of pi over 3 is radical 3. The cosine of 0 is 1, so secant is also 1. Tangent of 0 is 0, so we just have minus natural log 1. The natural log of 1 is 0, so this is the final answer. For number 16, notice that the curve is written in terms of y, and the limits are given in terms of y as well. So ultimately, we will be integrating with respect to y. Also, notice this problem is calculator active. We need to find the derivative x prime, and we could use the product rule, but I think I will try doing the distributive property instead. 1/3 y to the 1/2 power times y is 1/3 y to the 3/2 power. I'm adding those exponents. 1/3 y to the 1/2 power times -3 is negative y to the 1/2 power. Now we can find x prime using the power rule. 3 over 2 times 1/3 is 1/2. And then subtracting 1 from this exponent gives us the 1/2 power. The derivative of y to the 1/2 power is 1/2 y to the negative 1/2 power. So this is x prime. Here is the formula for arc length when we are integrating with respect to y. If we were doing this by hand, I would start by setting up the expression under the radical. Then I would manipulate that expression algebraically to turn it into a perfect square. However, This problem is calculator active, so I don't need to do any of that. I can just plug this expression for x prime right here. So this is an expression for the arc length from y equals 1 to y equals 4. All we have to do is type this into the calculator. For integrals, we do math 9. We are integrating from 1 to 4, and we want the square root of 1 plus, better put some parentheses here because we're going to have to square this expression, and then we have 1 half times y, well we can't use y, we have to use x, to the 1/2 power. Then we have minus 1/2 y to the negative 1/2 power. Again, we have to use x instead of y. And then all of this is squared. And finish it off with a dx, which we have to use instead of a dy. And that's it. So the answer is 3.333. These problems are a lot easier when you're allowed to use a calculator. This last problem is also calculator active. We need to find the total length of this asteroid shape given by the equation x to the 2/3 power plus y to the 2/3 power equals 4. And we're given the hint to find the length in the first quadrant and then simply multiply by 4. In order to set up the arc length formula, we need to find y prime. But first we need to rearrange the original equation to get y by itself. Subtracting x to the 2/3 power from both sides gives us this. We can get rid of the 2/3 power by raising both sides of the equation to the 3/2 power. Now that we have y by itself, we can find y prime using the chain rule. First we take the derivative of the outer function, which gives us this, and then we multiply by the derivative of this inner function, which is negative 2/3 x to the negative 1/3 power. This entire expression goes right here in the arc length formula. The portion of the asteroid in the first quadrant goes from x equals 0 to x equals 8. So this is an expression for the arc length in the first quadrant, but the length of the entire asteroid will be 4 times this. So I just put a big old 4 in the front. All we have to do now is type this into the calculator. So here's the big old 4. For integration, we do math 9. In this case, we are integrating from 0 to 8. Then we have the square root of 1 plus some stuff. So here we go, the square root of 1 plus. And then everything else is going to be squared. So we need to start off with some parentheses before the 3/2. Next comes 4 minus x to the 2/3 power, all raised to the 1/2 power. Looks like this. Next we have negative 2/3 x to the negative 1/3 power. And that looks like this. Time to close off the parentheses we started to represent everything that is being squared, and so now we've squared it. And finally we finish it all off with a dx. And that's it. We can either truncate and put the answer as 47.999, or we can round to 48.